So let us start with a new unit, which is elementary particles. And before going to see the classification of the elementary particles, let us see what is the classification of the fundamental forces. Because the classification of the fundamental forces will highlight the applications of the elementary particles, means what is the role of these elementary particles in the construction of these fundamental forces. Okay, so before going to the elementary particles, let us start with the classification of the fundamental forces. Generally, we classify forces into four types. First one is the gravitation, electromagnetic force, weak nuclear force, and strong nuclear force. So we know that this gravitational force field is due to the mass, and which is responsible for the holding of the solar system or holding of the galaxies at a particular place in the universe. So with the help of the gravitational force field, we can derive the forces between the satellites, planets, and the solar system. So this is the force which is responsible for holding all these things together in a universe. Now we know that this electromagnetic force is due to the charge. So in an atom, electron is revolving around the nucleus, which is due to the electromagnetic force of attraction. So whenever there is a charge, okay, so that charge is explained with the help of this electromagnetic force. So I will say this atom is held together with the help of this electromagnetic force. So weak nuclear force, when we convert a proton into the neutron, or when the neutron is converted into the proton, we call it as a weak nuclear force. This weak nuclear force we are going to discuss in very detailed manner. So what is the charge parity and time violation in this weak nuclear force. So how this charge parity and time violation is the characteristic of this nuclear force. So this nuclear force is we are going to study, we are going to have a separate lecture on this, so I will not talk much on this right now. So the strong nuclear force is present between the quarks, I would say. So this is present inside the proton and inside the neutron, or it is a force of attraction between the two protons or two neutrons, or a proton and a neutron. So the force of attraction between this is also called as a strong nuclear force, or the force which is present between the quarks, it is also called as a strong nuclear force. Thus we have classified almost all forces which are present in the universe. So these are the four basic fundamental forces which cover all these areas, okay, starting from the satellites, from the solar system, from the galaxies, to the protons, neutrons, and quarks. So these are the four basic fundamental forces we classify. Now different principles and laws are there which explains the different forces, but we are not at all interested in to those laws. Like gravitational force field, it is explained by F is equal to g mm upon r square. Okay, so this is according to the Newton's law of the gravitational. We are not at all interested in how these laws are explained, or which are the principles and theories which are explaining this, but we are interested in the particles which are involved in these four fundamental forces. And according to the quantum electrodynamic theory, which is very important, so the quantum electrodynamic theory, which is called as QED, which tells us that whenever there is a force between any two particles, that force is mediated with the help of some particle. Okay, and this particle is called as a gauge boson. This exchange particle. So what is the quantum electrodynamic dynamic theory is telling us? Whenever there is a force between any two objects, any two particles, that force is mediated by some exchange particle, and that exchange particle is called as a gauge boson. Now we are interested in gauge bosons which are involved in this all four types of the forces. So the gravitation is due to the graviton. So the exchange particle for the electromagnetic force is a photon. For a weak nuclear force, it is a W plus minus, or the Z boson. And for a strong nuclear force, it is a gluon or pion. Now we are going to see all these elementary particles in a next lecture in a classification of the elementary particles. Okay, so what I want to highlight is that, so this is the role of the elementary particles to cover up all the universal forces. Okay, so these particles which we are going to study, which we call it as elementary particles, so these particles are responsible for the fundamental forces. Okay, out of which this graviton is not yet discovered, but the photon, bosons, gluons and pions, and how we classify them, this is very important, and that we are going to see in the next lecture, which is the elementary particles. Now see, this gravitational force field, if I take the strength of this gravitational force field as 1, then this electromagnetic force field is nearly 10 raised to 36 times stronger than that of this gravitational force field. Okay, this weak nuclear force is nearly 10 raised to 25 times of this gravitational force field, and a strong nuclear force is nearly 10 raised to 38 of this gravitational force field. And the range of the, it is also having infinite range. The weak nuclear force is in the range of 10 raised to minus 18 meter, and this is in the range of 10 raised to minus 15 meter. So this is the strength of the four fundamental forces, and this is range where up to which these fundamental forces act on. But the most important point is the gauge bosons which are involved in these four fundamental forces.